Now to take into account, okay, so I gave this one. I thought some other industry, because some people other than aero industry, there are people some ASME-elliptic and there's a Langer static yield to represent the to take into account thing. I will explain next line. This is just to show that other than this 4 which is used in the aero industry, I mean proposed for aero industry is being also there are 2 are used, but they are not used in for aero industry. Is a Soderberg is there, Goodman, Gerber and Morrow. So what is exactly says? S is the stress amplitude of the applied stress. S is mean stress of the again applied loading. Then ultimate tensile stress of the material. Then equivalent stress for sigma min equal to 0. So this is very tricky to explain. Anybody knows what is it means equivalent stress? So what it says your equation showing what SA versus S mean. So your y-axis is amplitude, mean stress is your x-axis mean stress. So if you take as a Goodman equation, when mean stress is 0, here what is the stress amplitude is equal to S equivalent. Okay, so equivalent is become endurance when R is equal to -1. If other than R, then you have to find what is the equivalent. That I will explain down the line. Then when you substitute sigma amplitude 0 here, you substitute 0, first term will be 0, is equal to 1 means S mean equal to S ultimate. So ultimately fixed. And why you are getting SY, SU? Because it depends on the which equation you are referring to. See, in Soderberg it is restricted to SY because it is numerator denominator SY, and if you use Morrow's, it is going to flow stress. That is true fracture strength, which is beyond your ultimate strength. That's why you get value here. So as per the equation, is a square here. Obviously, your Gerber will get you the nonlinear. Fine. This equation is nothing but is the failure criteria of a structure subjected to certain amplitude versus mean. Because one cyclic load you can define amplitude mean. If it falls exactly any one of the line, that means failure equal to 1 means failure occurs. If anything less than that is a safe. Stress amplitude to here is safe. Now what exactly it says, this equation is, you have an applied stress of certain mean stress which is not 0. See, and also please keep in mind, if you have SN curve available for different mean stress or different R ratio, well and good, that's not an issue. Directly you can refer to it. Now question, if you don't have, how do you go about it? So what you do is, suppose you know for this cycle and all, assuming that you have SN curve available for this stress ratio, refer to stress range or S max for the given stress ratio and find out number of cycles to failure. Now what you are trying to do this, you are in the absence of SN curve available at mean stress of this applied stress, you find out how much you can increase the amplitude with mean stress is 0. Did I make it clear? That means it says transfer to 0 mean. That means what is the can you see that equivalent cycles with no mean stress? That means the damage that is being caused of a loading cycle with certain mean is same as you take SN curve of R equal to -1 but different amplitude at higher amplitude. To demonstrate the concept, you have a this stress ratio of say R equal to 0.1 and you are talking about applied stress, not refer to this figure, but imagine this is 100, 10, 20, 35, 40, okay, 135 megapascal is the S max, sorry, stress amplitude, sigma amplitude, right, is here. What is number of cycles to failure? 10 to the power 5, okay. But in the event you don't have R is equal to -0.1, what you do is you refer to R is equal to -1, which is available in the SN curve, readily available, or you have generated Buskin equation. So same 10 to the power 5, if you do that, we need around 235 megapascal. That means SN car of R is equal to -1. If you refer to 235 megapascal, whatever the damage you get, number of cycles to failure, is same as the applied stress having 135 megapascal with stress ratio of 0.1. So that is all Goodman equation is trying to get this SE equivalent stress in that equation. Got it? Shall I go to the next? No, in R is equal to -1, S max and SA amplitude same. Use that equation. R equal to -1. R is what? S min by S max. Okay. This is a physical concept of how to take care of Goodman equation. What it does actually. You are just finding out amplitude, equivalent amplitude of the applied stress correspond to the same damage that would have occurred using the non-mean 0 and with mean stress is 0. Okay. So in this case, you have considered Goodman and Gerber and all. Unfortunately, in air industry, they use out of Goodman and Gerber, but Goodman is using popular and extensive use because in Gerber equation curve, you have some experimental data also falls above and below. But in the case of Goodman, all experimental data are above the Goodman. It's a conservative. Like in Baskin equation, if you see, you have seen the slide, Baskin equation, all data are above the Baskin line. So it's a conservative. So this is conservative. And Soderberg is too much, too conservative. That's why Goodman line is used here. But why you are considering only positive? Because it has been shown in experimentally anything this is 0, right? All less than 0 is negative. So they found is insensitive. It doesn't affect your stress ratio. That's why if you recall, and one of the slide was telling the figure is showing R is equal to positive going below, no, and R is equal to compression showing higher than the R is equal to -1, but it's in reality doesn't make a difference. They fall side by side to R is equal to -1.